find the two x-intercepts of this function and show that the derivative is 0 between the two x-intercepts. Okay, so what we have first, well, first let's just find the intercepts. We set the function to 0, right? Algebra stuff. And we solve, and you should get x equals 0 and x equals -7 by setting each factor to 0. Okay, so here's what we're looking at. A real rough sketch is you have a 0 here. Whoops, I went the wrong way. A 0 here, call that -7. Okay, and then the idea here is using Rolle's theorem that if your function is continuous on this interval from -7 to 0, and the two endpoints, the output at the endpoints are the same, right? And then at some point, your function has to level off, or the derivative has to be 0 at some point on that interval between those two values. Okay, so that's what we got to find next. So the derivative, and I want to do this example specifically because this one comes up a lot, and the derivative is a little tricky with the algebra that we got to do. So let me show you what's going on here. So it's f prime. We got to use the product rule. Leave x alone. Take the derivative of, we could write that as x plus 7 to the 1/2. So the derivative would be 1/2 x plus 7 to the -1/2 times the derivative of the input, which would just be 1. And then I take the derivative of the other part of the product. Derivative of x is 1, and I leave that alone. Notice I'm not using the root notation, but rather the fractional rational exponent notation, because it allows me to do some algebra a little bit easier, I think. So the next thing, and this is pretty common, these types of problems, is we notice there's a factor of x plus 7 in each part of this sum. And the general thing we used to do in factoring was factor out the factor with the lowest power. So I'm going to do the same thing, see what happens. The factor, the common factor with the lowest power, in this case the negative. Okay, we want to see what happens when you do that. So that gets factored out, so you're left with 1/2 x plus, and then here's the question, x plus 7 to what power? Right? If remember when we factor, it's the opposite of multiplying. So x plus 7 to the -1/2 times x plus 7 to what power would give you the x plus 7 to the 1/2? And the answer is 1. And that's why it works out really nicely, because x plus 7 to the 1, I don't even need those parentheses. And then I can just combine like terms. 1/2 x plus 2/2 x is 3/2 x plus 7. And then this is going to be my denominator, goes down, x plus 7 to the positive 1/2. Okay, that's my derivative. And then finally, I just got to show it's equal to 0 at some point on the interval. So that should happen when the numerator, when I set this guy to 0, right, which happens when the numerator is 0. So 3/2 x plus 7 equals 0. Subtract 7 from both sides, 3/2 x equals -7, and then multiply by 2/3 to get my answer. And that should happen right in between at -14/3.